So this is a section in a manuscript that I'm completing on categorical data analysis. Hopefully, I will be able to finish my manuscript in 6 months, writing different chapters. This is a section from last chapter, and it is about causal inference. Yeah, let's get started. Before I start, I'd like to quote one of my favorite quotes from one of the most prominent statisticians, I think, in the last century, George Box. Essentially, more people are coming actually. Essentially, all models are wrong, but some are useful. This provides very, very sagacious perspective of statistics and data science in general. I think Box was very, very humble. There are two parts of my talk. The first is to give a conceptual introduction, pretty cursory, and I don't think does good service to causal inference, but give you guys a pretty quick introduction to causal inference and observational studies. And second, probably more interesting to some of you, is how to do causal inference with R. So in the second part, what I'm going to do is to cover propensity score matching, Mulholland bias, distance matching, full matching techniques, genetic matching, last but not least, coarse and exact matching. Okay, so first is to give you a very quick idea about what observational study is and what causal inference is. And here, I use these two terms interchangeably. So here, observational studies is equivalent of causal inference in this talk, and that might be very nuanced difference between these two. Observational studies is also called causal inference, especially in sociology, because sociologists love to make causal claims. You know, A is related to B, or a couple of variables are associated in the causal fashion. And propensity score analysis in general, not just in sociology, but across multiple disciplines. For example, social work and treatment effect in economics, pretty popular. What is observational studies? Cochrane in 1965 wrote a paper entitled The Planning of Observational Studies for Human Population, published in Journal of Royal Statistical Society in Britain. And in that article, he defines observational studies as an empirical investigation whose objective is to elucidate causal relationship. So it is to elucidate, to show the causal relationship, like cause and effect, when it is infeasible to use controlled experimentation and to assign participants at random to different procedures. So here, there are two key terms here, as I see it. First is, elucidate causal relationship. And second is, when it is infeasible to use controlled experimentation. And we know that not just in natural science, but in social behavioral science, controlled randomized experimentation is the golden template for rigorous quality studies to advance our theories and all kinds of arguments and hypotheses, and test our hypotheses. That is the golden template. But here, Cochrane introduces a scenario in which investigators cannot use controlled experimentation. They have to use some alternatives to randomized experiments. For example, analytical survey data or observational data. And to make some manipulation of the data, then to make causal claims about the relationship of a couple variables in the data. And that's also part of the reason why it's called quasi-experiments. Okay. So observational studies deal with data that do not meet the requirements for random assignment. And in a couple seconds, I will talk about randomization. What is randomization and why? So here, what do I mean by saying do not meet the requirements for random assignment? First is there could be self-selection going on, and there could be administrative selection by teachers, by bureaucrats, by legislators, by therapists, by physicians. Yeah. Okay. So here, since we're going through this unprecedented pandemic lockdown, here I'm just going to raise an example about COVID-19. For example, to come up with a COVID-19 vaccine, of course we're going to do experiments. Here I'm talking about big pharmaceutical companies, right? They have to do clinical trials. So for self-selection, that means the people who are willing to participate in such experiments, their attributes with regard to socioeconomic status, or, for example, altruism or other factors might be quite different from those who don't want to participate. Okay, so that's something experimenters, clinicians, physicians, they have to take into account. Not just self-selection, but sometimes we could have administrative selection, for example, to get into Head Start programs, to get into WIC, or to participate in GT programs in schools, right? Gifted and talented programs. There are some standards that students have to meet, or there are some biases that the teachers, bureaucrats have to winnow out certain, qualified individuals. So that's the problem that come with observational studies, making them not qualified or not meeting requirements for random assignment. There are two features of observational studies in general. First is that observational studies concern treatment effects. So in general, scholars, they want to know the difference in average outcome of different treatment groups. We could have multiple groups. Let's say the group who receives, let's say, COVID-19 vaccine produced by Moderna, okay, one of the pharmaceutical company, versus, let's say, another group who receives placebo. We could have another group which receives treatment from, let's say, some existing drug or some vaccine under production at Pfizer. So all are possible, and we want to know the average difference of individuals from these groups, then figure out which drug, which vaccine has high efficacy, etc. And observational studies can employ data from non-experimental. Of course, they can use experimental data, but sometimes the experimental data are not strictly speaking randomized come from randomized experiments. Right? Sometimes the data from non-experimental scenario, and sometimes they're simply from non-observational studies. For example, survey data. Yeah. So what really is causal inference? Okay, in simple terms, as I understand or understood very beginning when I got into this area, observational studies or causal inference is a very, very large umbrella covering a lot of techniques, but the goal is to approximate or simulate random experiments using observational, not experimental survey data. In sociology, for example, general social survey or similar survey data. Here, I want to kind of raise an example, actually about how, to begin with, to get into a more formal discussion about randomized experiments and randomization. First, I want to quickly introduce an example in the book by R.A. Fisher, the most prominent statistician in the last century, probably continues to be and still gonna remain so in the foreseeable future. In his book written in late 1920s and early 1930s, Design of Experiment, in chapter 4, he simulates or describes an agricultural experiment in randomized blocks. So the goal is to test relative productivity or yield of 5 varieties of a farm crop. And on a strip of land, he proposes to have 8 compact squares with 5 plots running from end to end of the block. Okay, and then within each square, randomly assign. He proposes to randomly assign one of the 5 plots to a variety. Then grow the crops, over a period of time. Then, he proposes to apply same agricultural treatments. Then after a while, he suggests to use ANOVA to compare the yield of these 5 varieties of the same farm crop. So in this study, he used randomized blocks. Also could be viewed as a randomized experiment, basically to look at the treatment effect, right? Treatment effect. In that book, he also talks about Latin square and the factorial design, the latter of which actually is to look at the effects of multiple factors, just manipulate multiple factors to see the treatment effect. So that is the kind of classic example of randomized experiments. And causal inference observational studies is to use, so here we have experimental data, but observational studies and causal inference is to use, usually use non-experimental data, okay? Survey data, observational data, to do a bit of data management, to somehow approximately meet the requirements of randomized experiment and to do analysis.